Okay, we're going to talk about integration by substitution, but first of all we're just going to talk about this idea of substitutions and how you've seen it loads of times before. So if we got some sort of equation, in this case a quadratic, say a x minus 2 all squared plus b x minus 2 plus c equals 0, we'll call this result star. This is a quadratic equation in x minus 2. And that's fine, we can solve that using the normal methods. But actually, just to make it neater, we might use the substitution u equals x minus 2. Then the equation star is au squared plus bu plus c equal to 0. And that's a little bit more familiar, and we just solve that, and then all we do is, once we found u, we revert the substitution, that's important, and then we get our solutions for x, okay? And they'll be the same solutions as if we just solved for x minus 2. So we can apply this sort of idea to integrals, a little bit of extra step and extra admin, but nothing too tricky. What is difficult is what was very easy in this example. It was very easy to see we pick u equals x minus 2 because x minus 2 was what was causing us the issue, and we just wanted a function of one variable. Well, and there you go, that's what you choose. Sometimes with integration by substitution it can be a little bit difficult to pick the substitution, but often for the examples you'll do, if you do enough practice, you'll get a very good intuition of what to pick, when to pick it, and why. Okay, but we'll get into an example, then we'll talk about that at the end. So if we have some integral I, and that's the indefinite integral from, not from, it's an indefinite integral of cos theta sine x dx. Now, this is just two standard functions multiplied together. We can plot the graph of this, so it makes sense that the integral should be well defined. But with our standard result, we don't actually know how to do this, so we're going to resort to integration by substitution. Okay, and the substitution I'm going to choose is u equal to sine x, and then I'm going to justify this retrospectively to give you the idea of how you can make these guesses, because that's ultimately what substitution is a guess. Okay, this is a well-known integral, so it's known that that's the guess you choose, but yeah, hopefully you get the point. So if we substitute that in, we get I is equal to cos x u dx. Now you might say that hasn't helped us at all, and you'd be right, but that's because we've missed a key step of integration by substitution. Now we have a function of two variables in the middle which we don't want. Okay, we just want a function of u now, and we're integrating with respect to x. Well, we have to integrate with respect to u if we've got a function of u. So that's the next step. We convert this dx into some function of du. So we do, that's terrible handwriting, du by dx and du by dx. So the derivative of sine x with respect to x is cos x, and that implies du is equal, dx is equal to du over cos x. This isn't strictly true, you can't rearrange things like this, but because of the chain rule, this works. Alright, so it's not that dx is equal to du over cos x, but the chain rule means that this sort of methodology gives you a substitution for dx, okay, and that's it. So what we do is, so now I is equal to cos x u du by cos x. Cos x is cancelled out, and that is now why I justify my pick of u equals sine x, because I knew the derivative of sine x and I worked through it quickly in my head. You know, I had an idea, I guess you think. We want to cancel out this, we want to get rid of this cos x and the sine x. How can we do that? or with a function that is sine x and its derivative is cos x. So that sorts that problem out. And that's kind of the idea. You have to think about the derivatives of things. You have to have an idea, a plan of how it's going to work. Your first pick of substitution might not always work. That's okay. Just give up on it and start again. But if you get quick at the examples, that won't be too time consuming, so it's not the end of the world. And all the examples you'll have to face at A-level maths are examples where one substitution will give you the answer. So sometimes you have to, later on you have to do one substitution, one change of variables for some reason, and then you'll have to change them again. Here you just have to do one substitution, okay, which is nice. So you should always be looking for a quick solution, I guess. And this integral of u with respect to u is just equal to 1/2 u squared plus c. That's nice and easy. So you see how we've turned a complicated integral into a nice and easy integral. This is not our answer, okay? We have to substitute in u equals sine x, and to get an answer in terms of x, okay? Because our integral was in terms of x. And this is 1/2 sine squared x plus c. Now, I encourage you to differentiate that, and you will, hopefully, if I've done my working out, and you know how to differentiate to get cos x, sine x. And you can see we do this differentiation with the chain rule, so integration by substitution is like the opposite of the chain rule, okay? You're having to guess the function that was the derivative of the original pick of u in the chain rule. I mean, that I've made that more complicated than it needs to be, but what I'm trying to say is if we were differentiating this, we would pick u equals sine x and y is equal to 1/2 u squared, okay? So when you're doing integration, you're trying to magically pluck up this u, okay, before you've seen the integral, which can be done. Okay, so thank you for watching this video. Hopefully it helped give you an idea how to do integration by substitution. I encourage you to do lots of examples, and if you are stuck on an integral or you look through a solution for an integral and you're not entirely sure why they picked what they picked or how they got to that conclusion, or you couldn't follow the method, let me know in the comments and I'll try sort it out for you. Okay, thank you very much for watching, and I hope to see you in the next one.